All right, we're going to do a little bit of exponent review in this lesson. This is lesson 3 in module 5. And then we're going to apply those rules to variable expressions. So let's do a little review. If I'm looking at letter A here, 1/3 squared really means 1/3 times 1/3. So it would be 1/9. So exponents, in one sense, are just repeated multiplications. Okay, B really means -1 times 1, which means 1 times 1 is 1 and then negate. Only the 1 is squared. The next one is -1 squared. That means the whole thing is multiplied by itself. So that's going to be 1. So be careful here. This square right here only applies to the 1 and then I negate. So we square the 1 and then negate. This one is I'm actually squaring -1. And -1 times -1 equals 1. Next one, D, the exponent always comes before multiplication. So we're going to do 5 times 2 to the 3rd really means 2 times 2 times 2. So would really equal 5. 2 times 2 is 4, times 2 is 8. 5 times 8, which is 40. And last but not least, I'm going to raise 1 to the 9th power and then multiply it by 3 to the 1st power. 1 to the 9th is 1 times 1 times 1 times 1 times 1 for a total of 9 ones multiplied together. You get 1. 3 to the 1st is 3. 1 times 3 is 3. Next. Now, let's take a look at the product rule for exponents. That says that if I have a base A raised to a power, and then again I'm multiplying it by a base A raised to another power, all I have to do is add the exponents and leave the base the same. So here's a little example here. And the way I like to look at it is A squared is really A times A, right? A to the 4th is really A times A times A times A. So if I think about it, I'll have A multiplied together a total of 6 times. So it's A to the 6th, so I add those exponents. Now if I'm looking for a power rule, I have A raised to a power raised to another power. I'm going to multiply those exponents. For example, x to the 2nd raised to the 4th would be x to the 8th. Think about it this way. X to the 2nd raised to the 4th really means x to the 2nd times x to the 2nd times x to the 2nd times x to the 2nd. And I add my exponents, I'll get x to the 8th. So now we're going to simplify each expression using one of these two rules. Part A says 2 to the 4th times 2 to the 3rd. Well, it's the same base, so I keep my base the same, add my exponents, so it'll be 2 to the 7th. Next one here, same idea, will be x to the 7th. Now this one, C, gets a little bit more challenging, and I'm going to write it out. It's 3st times 4s times s times t. So if I think about it, 3 times 4 is 12. I have 1, 2, 3, s to the 3rd, and then I have t times t, which is t squared, so there it is. Now let's do D. Yeah, let's. So I'm going to raise powers to powers first, so it'll be x to the 12th, because I multiply, times y to the 30th, and that's it on that one. And the part E on this one, think about it this way, will be 6 times x times y times -2, 7 of these x's multiplied together, and 2 y's. So 6 times -2 is -12, and then I have 1 x here, 7 of them here, so I have 8 x's. And then I have a y here, 2 of them here, for a total of y to the third. This next slide is just a bunch of exponent rules. The first one here is the power of a product rule, and that says that if I have a couple of numbers multiplied together within parentheses and I'm raising to a power, I have to raise the first one to that power and the second number to that power. So for example, here I have to raise 2 to the third and x to the third. So I will get 8x to the third. You can think of it this way. It's really 2x times 2x times 2x. 2 times 2 is 4 times 2 is 8, and that's where that 8 is coming from. The other one is the quotient rule for exponents. That says that the denominator can't be 0 in order to use this, but it never is. So what I would have to do is raise the numerator to that power n and the denominator, both of them. So for example, here I have to square both the 3 and both the x, so I'll get 9 over x squared. For the numbers, as long as the numbers are quote-unquote small, you should be able to multiply them out. Like 3 squared, you should never leave as 3 squared, you should do it as 9. The last one is the quotient rule for exponents. That says that if you have a to the m divided by a to the n, you're going to subtract your exponents to get the results. So for example, if I have 2 to the 4th over 2 to the 3rd, since I have 2 to the 4th over 2 to the 3rd, I'm going to subtract my exponents and get 2 to the 1st. Why does this work? Let's think about it this way. 2 to the 4th is really 2 multiplied by itself for a total of 4 times. 2 to the 3rd is 2 multiplied by itself by a total of 3 times. Now we can cancel or divide out the ones in the fraction. That would be 2's, and we're still left with 2. So that's the idea. The next rule is 0 exponents. A to the 0 is equal to 1 as long as a is not equal to 0. So let's take a look at this. Suppose I have 5 to the 3rd divided by 5 to the 3rd. Well, 5 to the 3rd divided by 5 to the 3rd is 1, but if I use that other division exponent rule, it would really be 5 to the 0 because I have to take away 3 is 0. So 5 to the 0 has to equal 1. Let's move on to the next slide. Okay, now we're going to use all of those rules and simplify each expression here. Well, I'm raising xy, both of them, to the 4th, so that will be x to the 4th, y to the 4th. This next one, first I have to raise that to the power of 2, so it's going to be 3 to the 2nd, s to the 2nd, t to the 2nd, times 4 s squared t. Now we're back to where we started. Well, 3 to the 2nd is 9, so let's simplify that first before we go simplifying the rest. Well, 9 times 4 is 36. We now have 4 s's and 3 t's, because this is raised to the first power, so I'm going to add my exponents. C says I have to raise both the numerator and the denominator to the 3rd power, and I'm done with that. So it's y to the 3rd over z to the 3rd. And D says I have to just subtract my exponents, so it's a to the 5 take away 2, which will be a to the 3. Next. Well, a little bit more work we have to do on these. So here it's 8 divided by 2. We're going to do that regular. There's no exponents involved. So 8 divided by 2 is 4. The a's, we have to subtract the exponents, so it would be a to the 7th. The b's, we have to subtract the exponents, so it's going to be b to the 1st. Remember, anytime there's no exponent there, it's a 1. Math people are lazy. They never like to write it. It's assumed. Now, suppose you don't get this at all. Maybe you're like, I just have no idea where she got all these things. Well, think about it this way. A to the 12th really means that. Oops. And b squared really means b times b. And these are all connected by multiplication. And now I can just cancel my little brains out. And what am I really doing? Dividing out the ones, because a divided by a is 1. And we're assuming these variables are not 0. So if you think about it, you have one b left, and then you have all these a left. Hopefully there's 7 of them, and yes, there are. And then 8 divided by 2 is 4. The next one is this. First, I'm going to do a little bit of simplification. Really, this is 21s to the first, t to the fifth, and 3s. Now, t to the 0, you guys, is just 1, so I'm going to just leave that. And now I am going to finish this off. 21 divided by 3 is 7. There's no exponents involved. You do the regular division. S divided by s is just the number 1. And then we have t to the fifth left over here. And now this one right here is a little bit tricky. It's going to be negative 8. I got to raise everything to the second power. X to the second, y to the what? The sixth, because when you raise power to power, you multiply. And then I have to raise the z to the second power. So negative 8 squared is negative 8 times negative 8. That's 64 regular. X squared, y to the sixth, divided by z squared. And I'm done. Because all these bases are different, you can't do anything else with it. Now you'll be able to do the written assignment after this lecture in your book, and also the My Math Lab assignment. Don't get discouraged. Once you use the rules and use them a lot, it's going to become second nature. So ask your teacher to keep clarifying for you, and don't give up.